Over the last few years, the Department of Meteorology and Atmospheric Science has welcomed several new faculty members. And over the next few months, we'd like to introduce some of them to you. To kick off this series tonight, we welcome Dr. Colin Zarzycki, who joined the department in January of 2019. Good to see you, Colin, and welcome to Weather World.
Yeah, good to see you too, John.
So before coming to Penn State, you were at the National Center for Atmospheric Research, what we like to call NCAR, and that's in Boulder, Colorado. Tell us about your time there and how that prepared you for joining our department.
Yeah, so I really enjoyed my time in Colorado. So NCAR is a large national laboratory. So we do a lot of kind of cutting edge research. We were doing kind of a lot of, boots on the ground type, real foundational work. So it kind of gives you a really nice background for what's going on in the meteorological field. The one thing you don't get is you don't get the interaction with the students, and you don't get kind of that academic kind of angle, which is one of the reasons why I ended up making my way here to Penn State.
Yeah, and we threw you right into the fire for sure. Now your bachelor's degree and PhD are in atmospheric science, but in between, you got a master's in environmental engineering. How has that sort of enriched what you do as an atmospheric scientist?
Yeah, it was a good experience. I didn't originally kind of plan exactly to do the atmospheric science, engineering, atmospheric science track. But looking back on it, kind of there are aspects of my research where I think a little more like an engineer, more practical, more applied, kind of more, what is it? How does this actually matter to somebody? How does this matter kind of to a general layperson? And I think having that viewpoint, both from kind of really understanding the nuts and bolts and the theory, but also understanding kind of like how it matters in the real world is, kind of a unique aspect that background brings me.
Yeah, and speaking of your research group in the department is called Modeling Extreme Weather and Climate. That's a great acronym, MEWAC. So what's the significance of having both weather and climate in the name of your research group?
Yeah, so my group is really interested in kind of operating in this space that is a little beyond what we think of for traditional weather forecasting. So when you're watching this show, you turn on the news, you hear the forecast, you're usually looking out a couple days, maybe at most a couple weeks in terms of predicting the weather. But when people talk about climate, you're thinking much longer time scales. Maybe what's going to happen next, summer, maybe what's going to happen in 5 years, 10 years, 100 years. Um, but what we're really interested in doing is kind of understanding how the weather that we experience on a day-to-day basis, you know, changes and interacts with these longer timescales. So, for example, are we going to get bigger or more frequent snowstorms in the future, stronger hurricanes? And these are things that are not important for just a predictive standpoint, but also long-term planning. So, building codes, flood mitigation, all of these things we need to be thinking on these longer timescales, which is kind of the space we're interested in.
And speaking of snowstorms, I saw on your website that you routinely produce what appear to be 7-day forecasts of essentially the probability of getting a big snowstorm in the Northeast US. Now, did you intend that to be for operational forecasters to use, or is it more research or both?
It's kind of a little bit of both. So we originally developed this tool to kind of quantify the significance of a snowstorm for use in our climate data product. So to say, are these big snowstorms, how are they going to change over the next 50 years? How are they going to change over the next 100 years? But what we've actually found is that you can use this tool and you can take a climate ensemble or a weather ensemble from the US GFS model, and you can essentially look at the probability of getting one of these big snowstorms over the next week. And the utility in that is not only can you kind of get an idea, well, are we going to get a big snowstorm or are we not going to get a big snowstorm over the next week? But it tells us something about the certainty with which kind of our models are telling us. Are they saying we're going to get kind of one of these moderate events and we're really sure of it? Or are we forecasting a moderate event, but it could be a total nothing burger, or it could be something that shuts down the whole East Coast for a couple of weeks? And that's kind of where the tool is useful.
And and in this modeling, I know you do some serious computationally heavy numerical modeling. What kind of computing power are we talking about here to run the kinds of simulations that you do?
Yeah, so the simulations that we run, they're not the type of thing that unfortunately you could just run on your laptop at home. So we use a couple different computers. For example, we have one big computer that we refer to as a petascale supercomputer out at NCAR. It's actually technically in Wyoming, so a little up the road from Boulder, Colorado. And those computers are essentially the equivalent. There was a number I calculated a couple years ago. If you took 32,000 MacBooks, the most expensive MacBook you could find on Apple's website, and you kind of like all glued them together. That's how powerful this computer is. So what the computer allows us to do is make many, many, many calculations at the same time. And that's what allows us to kind of run these really intensive weather and climate models. Because we're not only trying to predict kind of what's happening over State College or over San Diego, but kind of at every single grid point around the globe and perhaps hundreds of years in advance. So we really need that computing power to kind of understand what's going on.
Yeah, we're almost out of time, but you have my interest here. You were just talking about hardware, but you're the author of, or at least a contributor to, some software packages that are publicly available. Tell us briefly about some of those.
Yeah, so one of the things that my group is really interested in is kind of transparent and open source science. So a lot of the tools that we develop to kind of analyze these models. So for example, tracking snowstorms, tracking hurricanes, doing statistical calculations. We not only want to use that for our own research, but we also want to make that available for other people in the community.
Yeah,
So we do spend some of our time kind of writing the code, documenting the code, cleaning up the code in such a way that we can publish it publicly on places like GitHub so that other researchers can use that code to kind of answer science questions and
right.
effectively not reinvent the wheel. We
Yeah,
spend a lot of time on this. It doesn't really make sense for, all of the other grad students around the world to spend the same amount of time.
yeah, good point. We're out of time, Colin. Thanks so much. Dr. Colin Zarzycki, one of my colleagues in the Penn State Department of Meteorology and Atmospheric Science. Thanks for stopping by.
Yeah, thanks, John.